Hi there. Hopefully this will work again. Having technical difficulties. I've recorded this about 4 times now. Joys of doing things. Alright, distance. What I want you to do is I want you to tell me how much this person's distance is, which by definition is how far an object travels. So how far has this object traveled? And I guess like when referring to a person as an object is probably not the right thing to do. But nevertheless, how far has this object traveled? Well, he's traveled a total distance of 10 meters. He just simply walked down the block, which was 10 meters long. So his distance is 10 meters. Next question is what's his displacement? Going back to the definition of displacement, which you can only barely see on my screen. When I refer to the displacement of an object, the definition I'm trying to use is how far and in what direction an object is from its starting position. So if I'm referring to the displacement of an object, how far away is it from his starting position? Well, distance, or not distance, it's displacement, magnitude-wise, is 10 meters. So I'm going to write 10 meters, that's how far away he is. And I don't remember if I said this before. I want to make sure that I reiterate, if I have said this before, that distance, displacement, and position are all going to be in meters. They have to be in meters, international standards. Okay. Now I have how far, but the second part, in what direction. Now I've went ahead and I've put the origin over here. I put the coordinate system up here. So which way does he move? Does he move in the y direction or does he move in the x direction? Well, his motion here is entirely in the x direction. Okay. So he's moved in the x direction. What I'm going to do to say, hey, he's moved only in the x direction, is I'm going to put an x at the end of that. The problem with doing that is that if you know anything about algebra, x is a pretty common variable. So in order for you not to think of it as a variable and instead of as a direction, we're going to put a notation over the top of that, a hat. It looks like a little witch's hat. Nothing against anybody who's into Wiccan, but it looks like it's a hat. So I'll refer to this as x hat all the time. All that tells me is that the object is moving in the x direction. Okay. Now, to change it up just a little bit, what happens if he's walking in this direction instead? Okay, looking back at my coordinate system, he's still traveling in the x direction, but he's traveling in the negative x direction. So that means that his displacement is going to be negative 10. Okay, if he's moving from this point to that point, he's moving in the negative x. The way we express that is simply to put a negative on the other side. So if we were to talk about the opposite of an object's displacement, he moves in this direction 10. If I were to talk about the opposite of it, all I have to do is slap a negative in front of it. Okay, really nice tool for mathematics. Okay, so that's the object's displacement, 10 meters in the x direction. How about his position? Let's look at the definition. Location with respect to the origin. Now, where is his origin? I haven't established that. Okay, I have not established his origin. So that's the first thing I want to do. And how I want to do that is I want to take and I want to create an origin. The best choice for his origin, well, actually he really doesn't have the best choice for his origin in this case, but the simplest choice is to take that and put it right where he started. So that little red crosshair that I put in is representing his origin. Okay, so if that's his origin, then where does he end up? 10 meters. I'm just giving it a second for this computer to figure out what it's doing. There we go. He moved 10 meters away in that direction. Okay, 10 meters, and it's in the x direction. So he's 10 meters in the positive x direction from that origin. Okay? So there's a difference right there between at least this one and these two. Okay? I have that little x hat there to give me an idea of direction. Now, what I want you to do, and I'm going to go on and I'm going to make my way 3/4 around this block. I'm not going to go all the way around it. It's for you to do. What I want you guys to think about as you're doing this, as I'm doing this, as you're watching this, is there a way in which I can get a different value for displacement and position? So far we're getting the same values. Is there a way in which my positional value can be different than my displacement? Okay? Cool. So, next one, we're going to go ahead and we're going to go up, okay, 10 meters. You're going to go to the end of that block in that direction. Once again, your assignment is to determine the position is for that object.